Hello and welcome to the Volatile Compounds Lab. Now in this lab we'll be using these materials here to figure out the number of moles and then the molar mass of an unknown volatile compound. We see here that we will first start off by measuring the masses of these things, and by using that and subtracting it from the masses of the containers plus the compound, we can go ahead and figure out the mass of the compound. So step one is to weigh our round bottom flask. This will allow us to figure out what the weight of the glassware is. So you can go ahead and record that right now in grams. Now, notice how I just recorded the glassware itself, not that little stand that it was on. This is important because when I try to weigh the glassware plus the compound, I'll be able to subtract the two to figure out the mass of the compound. Next, I'm going to measure out 5 milliliters of the unknown volatile compound into this graduated cylinder. There you go. And over here, you'll see that I have been boiling a beaker full of water. Now, before I use that, I'm going to go ahead and pour my volatile compound into this round bottom flask. A round bottom flask is very useful because it will be able to house our vapor when it turns from a liquid to a gas. Go ahead and clamp it to make sure that that stopper is secure. And I'll go ahead and place that into the boiling water. What this will do is, now once I've secured it, the boiling water will be able to turn that liquid volatile compound into a gaseous one, which is the point we need to do. All right, so as we let the water boil, you can see that the inside of that round bottom flask has some of our liquid being vaporized and being condensed back down. You can kind of see the streaks and the marks coming down there. And all this time, or near the boiling point, I'm going to find the actual temperature of this boiling water. You stick the thermometer in there. You see it's about boiling temperature. It's close to 100 degrees Celsius. So to remind you what's going on, during this time, the liquid inside of this round bottom flask is being vaporized, so we can then find the total volume, which will be the volume of this round bottom flask later. All right, we see that the temperature has risen up to 98.7 degrees. So getting very close to that 100 degrees boiling temperature of water. Okay, so we see it is 98.6 there, and we've noticed that most of the vapor has stopped escaping from the top. So now it is time to condense down this vaporized liquid. So now I want to take that round bottom flask, which is full of gaseous vapor, and cool it back down. So I'm going to condense that gas down into a liquid by just submerging it in a cold water bath. So to kind of speed up the cooling process, I'm going to pour some cold water around that round bottom flask just to make sure that I can cool off the entirety of the glass surface. We can kind of see a little pool of liquid beginning to form at the bottom of that round bottom flask. And that is the gaseous vapors being condensed into a liquid. All right, we can see that little pool of water down, or pool of liquid in there, which means we've now condensed all of that gas down. And now we need to figure out what the mass is of that liquid inside, because that'll be our mass of our volatile compound. So we'll just move over here and go ahead and take the mass of our entire vent assembly and round bottom flask plus the liquid. So you can go ahead and record that. So 111.48 grams. Now, if we subtract that from our previous mass, which was just of the round bottom flask, that will give us the total mass of the liquid or the volatile compound on its own. All right, so now that I've cleaned and dried the flask, I'm just going to weigh it again to get a new initial or weight without the volatile compound. And I'm going to do that whole thing again. So I'll take off the clamp, remove the stopper. You can go ahead and measure out another 5 milliliters of our volatile compound. And this is of course, the same thing, but just for trial 2. All right, so 5 milliliters. Go ahead and place that inside of our round bottom flask. And submerge that in the boiling water bath. So now we can vaporize this liquid and do the same thing we did, but just time for trial 2. All right, so now that pretty much all of the volatile compound is vaporized, we should go ahead and check our temperature measurement of our water bath, which will also be the temperature of our volatile compound. See that it's very close to 100 degrees Celsius. And we can go ahead and condense down our gas. So we'll go ahead and pop it into our cold water bath. All right, and so over some time, we should start to see a pool of liquid forming at the bottom, right there. And that shows us that we're condensing our gas in this container into a liquid. Which will be our volatile compound plus a round bottom flask from just the round bottom flask. So that way we can get the mass of the volatile compound on its own. You see here we have about 111.34 grams. Subtract that from our previous one, we should be able to get just our volatile compound. All right, and then finally for trial 3, our initial mass is 110.64 grams, and that is of our empty round bottom flask. We will go ahead and repeat the steps that we did for the past 2 trials and measure out about 5 milliliters of our unknown volatile compound. Go ahead and clamp and cap that, and then stick that back into our water bath, our boiling water bath. And now we will wait until this volatile liquid becomes a volatile gas. So we can watch that small pool of liquid at the bottom of the round bottom flask disappear, showing that it's become a gas. see that pool of liquid is almost completely gone, showing that we've almost completely vaporized our volatile compound. All right, so now that we've completely vaporized it, we can go ahead and remove our round bottom flask from our boiling water bath, and we'll move it over to our cold water bath. So of course, this will, as in the other trials, condense our volatile gas into a volatile liquid. You can see the liquid beginning to pool at the bottom of this flask. Okay, looks like everything has condensed down, and we can go ahead and remove our round bottom flask from that clamp and dry it off, and go ahead and take its mass. So of course we'll subtract this from, or take the difference between this and just our round bottom flask mass, so we can get the mass of the volatile compound inside. All right, next we need to figure out the volume of our flask. So we'll weigh our empty round bottom flask once again. So record the weight there, it's about 110.86 grams. And now we will fill it with water. Now the reason we're doing this is to find the total volume of this flask. Since we don't know the exact total volume, by filling it with water and then multiplying that mass by the density of water, which is about 1 gram per milliliter, we can figure out the total volume that that water occupies, which will then be the same volume as our gas when it was totally vaporized. All right, so I'm going to go ahead and clean off all the excess water and weigh that flask once again. So now, record that weight, it's about 383.35 grams. We take the difference between that and the empty flask, and then we know that is the mass of our water. Finally, we're going to go ahead and measure the pressure of the room. So barometric pressure is a very similar thing to reading a thermometer, which is right here. So the temperature of the room, as you can see, is about 22.5 degrees Celsius. Now, the barometer is right behind the thermometer. So this level of mercury shows us the pressure of the room. So you see that level mercury line right there. So looking at the measurement, it looks like it's about 740 something millimeters of mercury. So to find out exactly, I'm going to move my measurement up here and see what it shows. So right there, this is about exactly 742. So 742 millimeters of mercury. That is our barometric pressure of the room. which was also the pressure of our volatile gas when it was completely filling our round bottom flask. All right, so now we found the pressure, which is P, and our PV equals nRT, our V, which is our volume, our mass of our volatile compound, and the temperature, which I took before removing it from the water bath each time. And we can use all of these to figure out the molecular mass or the molar mass of our volatile compound. Okay, and that is all. Thank you again for watching.